Question 2004. So a heart suffering from disordered muscular contractions is treated by applying electric shocks using a convenient apparatus. In order to study the functioning of this apparatus, we use a source of DC voltage of adjustable E. We have a double switch, we have a resistor and a capacitor, which is initially neutral or adjustable capacitance. We connect the circuit represented in the adjacent figure. So for first part A, the switch now is turned into position 1 here. So part A, give the name of the physical phenomenon that takes place in the capacitor. So it's the charging of the capacitor. Specify the values of the current in the circuit and the voltage UMN, which is U across the C, after a few seconds. So here, in order to find part B, so I is equals to 0, while UC is equals to E. This means when we are saying here after a few seconds, this means at the end of the charging. Now, how can we verify it? So by applying law of addition, we can say that U of the generator is equal to UC plus UR. But at the end, we have I equals to dQ over dt, which is equals to 0, which means that E equals to UC plus 0, which means that UC is equals to E. Now, part 2, the switch is now turned to position 2 at an instant taken as new origin of time t0. Derive at the instant t of the differential equation, giving the variation of the voltage UC as function of time. So now we are using a part 2a, we are doing the discharging, which means according to the law of addition, we have U of the generator, so U of the capacitor is equal to U of the resistor, since now we are in this position, which is position 2. So U of the capacitor equals to R times I, where I have minus dQ over dt, means minus C duC over dt. هلا بنعمل substitution, so رح يطلع لنا in this case U of the capacitor equal to minus R C duC over dt. بجيبها لهيدي الجهة, and then I can divide by RC, and I can divide by RC. So يطلع لنا duC over dt plus UC over RC is equals to 0. This will be the differential equation. The expression UC equal A exponential minus T over tau are where A and tau are constant, the solution of that equation. So the question is determine A and tau in terms of E on R and C. So we have its solution. This means verify the differential equation. So that means differential equation of the form duC over dt plus UC over RC is equal to 0. So we have UC equal A minus over tau. So we do the derivative, duC equals to minus A over tau E minus T over tau. And we substitute, so هيطلع لنا implies we'll get minus A over tau E minus T over tau plus UC اللي هي and over RC is equal to 0. We take common factor. So هيبقى معنا minus 1 over tau plus 1 over RC is equal to 0. And then now the question is to find tau. So which this means that 1 over tau is equal to minus 1 over RC, which means that tau equal to RC. So هيك نكون طلعنا the first part, first unknown. Now the question is to find A كمان. In order to find A, so we'll take initial conditions. So initial conditions. We have at t equals to 0, UC is equals to 0. So at t equal to 0, UC is equals to 0. So إذا جينا حتى UC is equals to E. We are here in the discharging process. So if we put here E by substitution, so we have E equal A, E to the power 0, which means that A equals to E. Derive the expression giving the current during the discharging as function of time. So لنطلع current, we say that I is equals to C duC over dt minus C duC over dt, which means it's equal, so إذا ما نجي نعمل derivative, duC over dt is equals to minus C and E over tau, so هيطلع لنا between bracket E over tau minus T over tau which means that's equals to E times C over RC E minus T over tau. We simplify, so هيطلع عنا means I equal E over R E minus T over tau. This will be the current. Using now the energy needed to save the life of a patient during an electric shock is 360 joules. This energy is supplied by discharging the capacitor through the patient's chest. Consider as the resistor of resistor R equal 50 ohm during a certain time, which is T1, that can be controlled by the switch. Now the capacitance of the capacitor adjusted to the value C equals to 1 millifarad and discharged on the voltage E equal 1810 volt. Determine the energy stored in the capacitor at the end of the charging process. So in order to find the energy stored, W equal half Cu square. CUC square. At the end, this means UC is equals to E. So it's equals to half times C times E square, which means it will become, which is 1810. So هيطلع معنا the answer is equal 1638 joules. The discharging starts at T equals to 0. At the instant T1, the energy delivered to the patient amount at 360 and the switch is then open. Calculate the energy that remained the capacitor at the instant T1. So لما نطلع energy that remained, we just do is part A. So we just do remaining is equals to W total minus W lost or delivered, which means it's equal 1638 minus 360 joules. So هيطلع عنا the answer is 1278 joules. Using the results of the above theoretical study, determine the value of T1. So نطلع value of T1, نطلع I1, نطلع time قد بيساوي. But we have what? We have the energy. So if you have the energy, then we can find UC. هنطلع time. لازم نستعمل UC, which is equals to E minus T over tau, and find the time. So if we find UC, we can find the time. But we know that the remaining part of the energy is equals to, the remaining part is equals to 1278. So this means we can say 1278, which is equal to half CUC square. And we have C is equal to 1 millifarad, 1 times 10 power minus 3, which means that implies UC square is equal to 2 times 1278 and over 10 to the power minus 3. So by doing the radical, we'll obtain UC is equal 1599 volt. لما نطلع UC, so we can find the time. So by substitution here, هيطلع معنا here 1599 is equals to E, which is 1810 exponential minus T over tau. With tau كمان we have it. So we divide, يطلع لنا E minus T over tau is equals to 1599 over. And we put len, so بندخل اللن من الجهتين, which means that minus T over tau is equals to len of over 1810 and implies, so T equals, the time is equals to minus tau len of 1599 over 1810, where tau here is equal to R times C. So R, this is R times C, and we have R here 50 ومعنى C it's 1 millifarad. So وحيطلع عندي answer it's 50 times 10 power minus 3. And the total answer will become 6.2 times 10 power minus 3 second, which means 6.2 millisecond. And the question at the end is to find also the current at the end of the electric shock. So نطلع current at the end of the electric shock, we'll substitute the time. So نحن معنا إنه أخذت وقتها قد إيه هالقد. So in order to find the current, we just do here part 2. We have I is equal to E over R, E minus T over tau. So شو بنعمل؟ بنعوض الT اللي طلعت معنا هي 6.2, which means it's equals to 1810 over 50, E to the power minus 6.2 over 50. And then we get the answer, it's equals to 32 ampere.